My name's Nicole.
My name's Jessica.
My name's Nick.
And my name's Nikki.
For our research project, we looked at land cover as an indicator of climate change in the Bowling Green State University area. We worked closely with Dr. Haney and GLOBE, which is a K-16 environmental education program. GLOBE supports 5 different areas of study, but we concentrated on land cover. We had 3 research questions that we set out to answer. Number 1, what covers our land in the 15-kilometer by 15-kilometer area surrounding the Bgsu campus? Number 2, how has the Bgsu land cover changed over time? And number 3, is the iPhone using the simple GPS application as accurate as other GLOBE-certified GPS devices? So you may ask, why do we study land cover and climate? We study land cover because the land cover change affects the temperature and the water cycle, along with the water cycle and temperature affecting land cover. For example, trees hold water while open land allows for direct evaporation, and buildings hold heat while green space cools it.
For our research discovery, we needed a wide variety of materials. First, we needed to know where this 15-kilometer by 15-kilometer range was located, so we had to have knowledge of our pacing as well as measuring devices to make sure this information was accurate. We also needed a whiteboard in order to know where our pictures are being taken and have a clear record of where they are from. We also needed 4 different GPS systems. 2 of these came from Jody and Nikki's iPhones using the simple GPS application. The other one was a Magellan Explorers, and the third one was the eTrex. Another tool we needed was the Muck Field Guide or the Muck Field Guide app available for iPhone.
For our methods for research question number 1, we started by examining Landsat images and Google Earth images to predict land cover types, and then we decided which area around Bgsu we wanted to visit. Once we were there, we found the center of the area and took GPS coordinates. We mucked, which is identify land cover by name and code, and took pictures north, south, east, and west. Then we submitted data to GLOBE website and finally created thematic maps using multi-spec software. Research question number 2, we compared percentages for each muck over the 3 time periods, starting in 1994 and ending in 2011. We chose to start in 1994 because that is our birth year and also GLOBE's, and also Nicole's birthday is the day that GLOBE was launched. For research question number 3, we collected GPS data from 34 locations on the Bgsu campus using all 4 GPS devices and conducted statistical tests on the GPS data to see if there were any differences.
For the results of our first research question of what covers our land in the area surrounding the Bgsu campus, we found it consists of 10 types, with agriculture being the most dominant. Other types that are included are transportation, industry, golf courses, wetlands, and forests.
For research question number 2, how has the Bgsu land cover changed over our time period? We found that there was the largest growth in transportation, industry, and residential areas, which you see in orange, white, and black on our maps, and the largest decline was in fields and prairies and agriculture, and also a smaller decline in parks, recreational fields, and cemeteries, which you see in the different shades of green on our maps. Overall, we found the green spaces decreased by 38.9% and non-green spaces increased by 38.9%.
For our third research question on whether we can use the iPhone, the answer is yes. The iPhone works just as well and sometimes even better than the GLOBE-certified GPS devices. For latitude and longitude, the iPhone was pretty much the same as the Magellan and Garmin GPSs, but when we got to elevation, the Magellan was a lot worse and less accurate than the iPhones, which is pretty awesome for the future GLOBE research.
Now to the discussion, looking at back to research question number 1, what covers our land. By finding our land cover types, we can see how this is going to affect the climate, as well as now we can identify green spaces that should be monitored and sustained within the area. For our second research question, by seeing how the land cover is changing, we're finding that there's an increase in carbon output and a decrease in carbon storage, which results in our carbon footprint increasing. As well, we found that regional temperatures are going to increase, as well as biodiversity will be affected. For the third research question, by finding that the iPhone GPS application is accurate, it's quite revolutionary in the sense that people all over the world can easily and accurately now collect GPS data using their iPhone instead of having to go out and purchase a GPS unit. And it's also revolutionary in the sense that as future teachers, all of us can now take our class out without having to purchase a GPS unit, and just by using our iPhones to collect data.
In our study, we found that there were several limitations and improvements that could be made for the future. When using our 1994 map, we had Landsat 5 images. These were not as clear as the Landsat 7 images when Landsat 7 was launched in 1999. So for our 2005 map, we had the Landsat 7, and for the 1999, we had Landsat 5. When looking at the 2011 map, we had to go back to Landsat 5 because Landsat 7 happened to malfunction in 2009, giving us less clear results. As it turns out, NASA has just launched last month Landsat 8, leaving us hope for the future of very clear images.
And that concludes our presentation. Thank you for listening.